Vitamin C, also known as ascorbic acid, is probably one of the most important vitamins that actually exists inside of our diet. Humans used to be able to make it, but are unable to anymore because we simply do not have the enzymes to actually do so. I think it's us, some sort of guinea pigs, bats, and apes are also unable to produce vitamin C, but other animals like dogs, cats, cows, you name it, are easily able to because they have the enzymatic capacity to do so. What happens when you don't get enough vitamin C inside of your diet is that you will suffer from scurvy. Scurvy is probably the one deficiency that you would have heard of inside of your school environment, and scurvy can be defined by some symptoms like bleeding, a lot of bleeding. Your gums can start bleeding and your teeth can even fall out because of that internal bleeding. Your hair can start falling out and you can suffer from a lot of skin, paleness and discoloration and general weakness and fatigue. Now, to avoid this horrific deficiency, which will eventually lead to death if you do not get it treated clinically, to avoid it, you can have fruit and vegetables. Vitamin C is, I think, the only vitamin that is not found inside of meat, and so you must have some fruit and veg in your diet or supplements to actually be able to obtain this chemical. And citrus fruits are the group of fruit and veg that have the highest amount of vitamin C inside of them. And that is because vitamin C is an acid, ascorbic acid, and citrus fruits are generally quite sour and acidity, so that can be explained by that as well. But it's often contained inside of like green leafy vegetables and loads of other plants. Another thing with vitamin C is it is chemically destroyed when storing and cooking. Quite a fragile vitamin. It contains a lot of electronegative elements and a lot of reactive bonds that can be broken by this heat and I guess just general sort of existence inside of air, and the oxygen inside the air can oxidize it sometimes. But yeah, that is why vitamin C is so important for you to get on a daily basis, as well as the fact that it is water soluble and will be regularly excreted by the kidneys and is not stored well by the liver. Now, ascorbic acid is an acid, yet it does not contain any carboxylic acid groups, which is the only sort of acid group inside of organic chemistry that is directly an acid. There's other things like acid anhydrides, which when dissolved in water can become an acid, but that acid is a carboxylic acid. So that doesn't really matter, but this ascorbic acid contains absolutely zero carboxylic acid groups, and the reason that it is able to be acidic and donate protons to other things is because of the whole lactam-enol structure ring that is contained inside of its molecule. Inside of ascorbic acid, you have two OH groups and one carbon-oxygen double bond. When a proton dissociates from the oxygen to become an O-, there is a lot of electron delocalization inside of this ring moiety, which means that this O- isn't as much of an O- as other things that aren't able to be acids if a proton dissociated from an OH group, such as ethanol, for example. And this will mean that the negative charge of that oxygen is actually kind of spread out across the entire molecule. And I'll put an image up on screen. You'll notice that there's a sort of equilibrium between the acidic forms of this molecule where there's an O- at different points on the molecule. That can also be another part to play and another factor in how this molecule is acidic, but doesn't actually contain any carboxylic acid groups. Now, another interesting chemical property of ascorbic acid, which is why I'm also going to name this as a chemical of the week, because it has so much interesting stuff about it, is that its natural form is known as L-ascorbic acid. That is a form found in nature. That is the form that you'll often find in supplements. I actually have some vitamin C supplements that I'm going to show here. Inside of the ingredients, it says sodium L-ascorbate. That is because this ascorbic acid molecule has chiral centers which contribute to stereoisomerism inside of the molecule, and that means that when in the 3D plane, the molecules can actually be shaped differently but have the same structure when in the 2D plane, when there's no sort of 3D lines or anything going on about it. This molecule has two chiral centers, which means that it can be, I guess there is a lot of stereoisomerism. This whole chiral center thing is quite hard for me to wrap my head around. But essentially, if you just imagine stereoisomers, they're like mirror images. If you imagine your hands are mirror images, but they cannot be superimposed and so are not the same thing, that is essentially the same thing with these chiral molecules. And so because these molecules can be shaped differently in the 3D plane, you're going to want the right kind of ascorbic acid, which is shaped in the right way to actually contribute to the things that vitamin C is good for. The other form of ascorbic acid, D-ascorbic acid, does not treat scurvy, does not prevent scurvy, and if you're being like scammed by some shady supplement maker that contains D-ascorbic acid, that's not going to do anything to help your scurvy whatsoever, because that specific structure, shape of ascorbic acid cannot actually do anything, do its functions, because it's not able to it's not got the sterics to actually do anything about it. Now, one of its first biochemical functions, when you literally just ingest ascorbic acid when it's going through the digestive system and before it's going to be absorbed, is it helps with the absorption of ferric iron. You may have heard the word ferric and ferrous before. Ferrous iron is Fe2+, and ferric iron is Fe3+. Ferric iron cannot be absorbed, but ascorbic acid helps it turn into ferrous iron, which can be absorbed. And that is because ascorbic acid can donate electrons and still be stable. It can donate electrons to this 3+ molecule, and because electrons are negative, it will donate a single electron to become 2+ and ferrous and able to be absorbed. That ascorbic acid will then go through a couple of structural changes, and it will still be stable itself and be able to do other functions inside of the body. Now, that relates to its main chemical function and main biochemical function, which is good for our health, which is that it is an antioxidant and a free radical scavenger, and is able to donate electrons to these free radicals to stabilize them, yet still also be stable itself. And to go through the quick little mechanism of this sort of free radical scavenging and antioxidant mechanism, it's not really that complicated at all. But if you imagine that ascorbate ion, this ascorbate ion is going to donate a single electron off of the O- to disarm a free radical and make sure that that free radical is now stable and ionized. And then that ascorbic acid is now itself a free radical. It will then turn into dihydroascorbate, which is where all three of the little bonds off of the 5-membered ring actually become carbon-oxygen double bonds, and now there's no alkene group inside of the ring. And as well as free radical scavenging, which is its main function in contributing to the health, and I'm pretty sure it contributes in other ways to the immune system as well when it comes to fighting bacteria and viruses and all that sort of stuff, it can help regenerate other antioxidants like vitamin E, which can also then be used to scavenge free radicals. And it's actually useful for the development of collagen. Now, collagen is a protein, a very, very long polypeptide, which builds up our skin, builds up our hair, blood vessels, and bone cartilage as well. Vitamin C is involved in the protein synthesis, in the sort of from random amino acids to collagen that's inside of and doing its functions that it needs to do. Vitamin C is involved in that process somewhere, and without vitamin C, you're going to have less collagen. Less collagen means less sort of functioning skin cells, hence the pale skin. Means you're going to have less functioning gums, hence the bleeding gums. Means you're going to have less functioning blood vessels, hence the internal bleeding and the bleeding gums as well. Your hair will kind of stop growing, and as I say, may even fall out. You're then gonna, I think there was another thing, your bones will get weaker, hence the weakness. Muscles and joints will get weaker as well, hence the weakness. And a lot of my vitamin videos so far, I haven't really explained the deficiencies for these vitamins. One, because some of the deficiencies of these vitamins are not common at all, because they're found in a lot of types of foods. But I wanted to explain vitamin C deficiency scurvy because I thought it would be interesting, because it probably is the most common deficiency that exists on the planet, and you could be suffering with it right now. And I hope that this video has helped you with that and understand what's going on inside of your body and why you actually need vitamin C. I wanted to do another little thing. I bought some vitamin C supplements recently and thought I'd just talk about them, I suppose. 1,000 milligrams per tablet, which is quite a lot, way more than the RDA, but the RDA is quite generous with vitamin C. And vitamin C, it's hard for it to become toxic because it's water soluble and therefore can be excreted regularly. It says that it supports, I mean, it might be inverted on here, I don't really know, but it says immunity, supports immune system and stuff like that. It's a chewable tablet, even though it's not really like a gummy kind of thing. It contains a couple sweeteners, sorbitol and sucralose, so it doesn't taste of disgusting powder, but getting basically a gram of vitamin C is absolutely insane compared to the tiny amounts of sweeteners that are actually contained inside of this thing. This stuff is incredibly good for you, and I just thought I impulse bought it one day, and it contains 120 tablets, and I've had about 3 so far. And I'm not going to have it every day, because 1,000 milligrams of vitamin C is quite a lot. And when you're not ill, because as I say, vitamin C can help respond to pathogens and viruses, it's not exactly the most useful thing. If you take it when you're not ill and you feel perfectly fine, it's kind of going to waste in a way because it's so water soluble and gets excreted quite easily. But yeah, that's about it for vitamin C. Chemical of the week. Hope you enjoyed and learnt some new stuff about it. But with that, I recommend subscribing for more content like this, and have a good day.